Objective 3 in Topic 2 is using sequences in real-world situations, or more specifically using sequences to model real-world situations. In this video, I'm going to do one example problem, and I'm going to ask you to do 2 of them on your own to check your work. Now, I've labeled again, I've organized this in steps. I've done an A, B, C, and D. On a test, you might not necessarily get this order of steps, but this should help you organize your thoughts in order to answer these questions in its fullest extent. So, for number 10, this example, it is a word problem. And with all word problems, the goal with word problems is to pull out information that is necessary, organize it in a way that makes sense to you, and then consider what the question is asking you. So, your favorite aunt decides to give you 1 penny beginning on October 1st. Each day, she gives you double the amount from the day before. So she gives you 2 pennies on the 2nd, 4 pennies on the 3rd, and continues the pattern that exists here throughout the month of October. So the first question that's asking you, I guess that's easy to understand because they bulleted it like this. Is this sequence arithmetic or geometric? How do you know? And what is the common difference / ratio? So we have to consider if it's arithmetic or geometric. Now, again, in order to do that, you have to determine, does it have a common difference or a common ratio? But for me, I don't even know what the numbers are yet that we're working with. I need to organize them in a way that makes sense to me so that I can look at them differently. And I'm going to make a table of the data or information that is given to me. So I will draw a box or a rectangle. Like so. My header is going to be, like always, N and A sub N, inputs and outputs, and I need 4 terms, the first 4. Make this as nice as possible. Alright, now inputs again, if I want the first 4 terms, you can read from the word problem, it says beginning on October 1st. Then each day, so on the 2nd, and on the 3rd, and then eventually on the 4th, the money will double. So my inputs are going to be 1, 2, 3, 4, representing the months of the year, or the days of the month, sorry. So, on the 1st, she gives you an output of 1 penny. I'm just going to put 0.01. On the 2nd, and it says each day it doubles, double the amount. The word double should jump out at you, meaning that it's going to change between each term, but we'll talk about that in a little bit. It doubles, so on the next day you get 0.02. On the 3rd day, you get 0.04. And hopefully you can do this in your head. Doubling of 0.04 becomes 4 times 2 is 8.08. So I have the first 4 terms, and I've labeled them in a sequence. In a table. Inputs of 1, 2, 3, 4, outputs of 0.01, 0.02, 0.04, 0.08. Now, I have to determine if this is arithmetic or geometric. I'm going to check to see if it's geometric. And I'm assuming that it's geometric because, again, if you look at the outputs right here, it looks like they're increasing between each term. 0.01 to 0.02, and then 0.02 to 0.04. It looks like the difference between those numbers is getting bigger each time. So that's a clue that this is geometric. So I'm going to test that out. I'm going to take the 2nd term, 0.02, divided by the 1st term, 0.01. And that equals 2. I can try that in a calculator, but I know that equals 2. Now let's check the next 2 terms. 0.04 divided by 0.02, 3rd term divided by the 2nd term. And that also equals 2. So because this is the same and because I am dividing, I know that it's geometric. It's geometric because it has a common ratio. So I'm going to write it is geometric because it has a common ratio that's common ratio of 2. So R equals 2. Alright, I have satisfied all of part A. is the sequence arithmetic or geometric? I said it's geometric. I answered, how do I know? It's because it has a common ratio, and I said the common ratio is 2. Done with part A. Moving on to part B. Write an equation to represent the sequence. All that means is what's the explicit formula for this specific sequence, all right? I know that it's geometric, so I know that it's going to be multiplication, and I'm going to put a sub n, because every explicit formula starts with a sub n, equals my first term listed, a sub 1, and in this case, a sub 1 is right here, 0.01, times my r, which is 2, raised to the n minus 1. This is a very important piece of this process because now this explicit formula is going to help us answer the rest of these questions. All right, so the next question is, how much money does your aunt give you on October 17th? So on October 17th, that's a specific value that I care about. So I have the first 4, 1, 2, 3, 4. I could just keep doubling it until I get to 17. I suppose that's fine, but I'm going to use my explicit formula to evaluate ace of 17, the 17th day. So I'm going to write ace of 17 instead of n. In this case, n equals 17. That's the thought process behind it. So wherever I see an n, I'm going to replace with 17. So ace of 17 equals 0.01 times 2 raised to the 17 minus 1. And that is going to give me how much money she gives me on the 17th day of October. So if I put 0.01 times 2 raised to the 17 minus 1 in my calculator, exactly like I see it, make that a better one, I get $655, not $665, $655 and 36 cents. So if you can tell, doubling your money every day is very advantageous for you because in 17 days, she's going to give you $655. So that answers part C. Now part D, what is the total amount she gives you from October 1 to October 15 inclusive? We haven't technically learned this yet. It's a sum formula, so you could again do a lot of long-handed work and list out all the amounts of money you have on the first day, second day, third day, fourth day, fifth day, sixth day, just by doubling it each time and then adding all those up together. That's going to take a long time. So there is, lo and behold, there is a formula for that. Everything in math has a formula, and so we haven't learned that formula yet, so we're going to leave part D blank and then come back to it after we learn the sum formulas for these types of problems. So at this point, after part C, I am done. I've answered a specific amount. On the 17th, she's going to get $655.36. All right, so this is A, B, and C is just answering specific questions about a sequence, and this is what I want you to be able to do as well. So I've given you 2 problems to do that mirror what I just did pretty closely. So your first part is to draw a table, come up with an explicit formula, and then it's going to ask you to evaluate a specific day. And then again, a specific day. All right? So go ahead and pause the video and try these 2 on your own. At this point in the video, you should pause this to try example 2 and example 3 on your own. Alright, example 2 is discussing giving away posters as a promotion. I have created a table. My first term, they say on May 1st, is you have 500 posters to give away. So my first term is 500. The second term, then on May 2nd, it says they will have 487. Third term at 474. And so 500, 487, 474. It looks like my numbers are going down. It looks like they're going down by the same amount each time. And I found that over here, I determined that it's arithmetic because I took the second term minus the first term. 487 minus 500 is negative 13. And then third term minus the second term is also negative 13. So I determined it has a common difference of negative 13. All right, so it's going down by 13 each time. So I wrote that out. It's arithmetic because of that. Difference is negative 13. And that's how I found the fourth term. It didn't give me the fourth term, but I could assume that the fourth term will be the third term, 474, plus a negative 13 or minus 13 equals 461. That's how I determined the fourth term, because again, I wanted 4 terms. That's part A. Part B, I wrote up my explicit formula. The first term, a sub 1, 500 minus 13. Again, I put minus 13 because my difference is negative. So minus 13, you could do plus at negative 13, but I want you to clean it up. Times n minus 1 to finish out the explicit formula. Then it asks how many flopper posters will be left on the 14th. So I just entered in, my n is 14. I entered in n here instead of here. I put 14, and then for this n right here, I put 14. And then I solved it. On the 14th day, they will have 331 posters left. Now, moving along, this one was a little bit harder because they didn't give you any numbers. They just gave you the beginning number. They gave you a sub 1. So on the first workout, you lifted 145 pounds. Then your trainer tells you to add 5 pounds for every workout. All right? That's why I circled that. That was an important piece of this word problem. You squat 3 days a week isn't necessarily important information to solve this, but she tells you to increase the weight by 5 pounds for every workout. So I just showed my my thought process there. You start with 145. The next workout, you're going to increase 5 pounds, so 145 plus 5 is 150. So my second workout, I'm lifting 150. My third workout then, I'm lifting 155 because of this math. And then my fourth workout, I'm lifting, right over here, sorry. I'm lifting 155 plus 5 is 160. So that's how I found all of those numbers. I just added 5 for each workout. So that's my list of first 4 terms, 145, 150, 155, 160. I wrote an explicit formula. I'm sorry, to answer that, I knew that it was arithmetic because it had a common difference of 5. I'm adding 5 each time. And it told me that up here. Increase the weight by 5 pounds for every workout. So I knew that was the common difference. Now, my equation, 145 plus 5 times n minus 1, and then it wanted to know how much weight would you be lifting if you continued this time, for 21 workouts. What's the weight you would be lifting on the 21st workout? So I determined that my n of my explicit formula was 21 based off the information it gave me. So I inputted I inputted 21 in for my n's right there and right there. And I solved this. I typed this into my calculator. 145 plus 5 times 21 minus 1. And I determined that on the 21st day, a sub 21, I would be lifting 245 pounds. And side note, this is actually a workout that is done by a lot of different athletes. And if you notice, you started at 145 pounds, 21 workouts later, you've increased it by 100 pounds. It's pretty good. So please check your work with mine. If there are any discrepancies, please check with a neighbor first and then raise your hand because, again, this is a very important skill that you'll need to be able to perform on the test.